And now we have a few minutes left for any kind of questions. Anybody wants to go first? Yes, please.
So all wonderful talks, so thank you for all that. My question is for Jonathan. Really beautiful. What a powerful system with that enhanced mutagenesis. Does the Cas9 effect, is that something unique to GIST, or have you tried that in other cell lines or other cell types? Because it's really, this evolution is really quite impressive.
Is this on? No, it's not.
Doesn't work either.
If you can figure it out, Philip. So it's idiosyncratic, Patrick. It works incredibly well for cell lines. Like, we couldn't believe when we took a GIST that had exon 11 plus activation loop and put it under repretinib selection with the, I thought, like, we're not going to get apples. And we got them right away, And we've done it leaving out the ENU, you got to have that. Leave out the Cas9, you have to have that. We've done it with inducible Cas9. We're working on, is it good to have a low level or a higher level, and how long do you need it for, and so forth. So there's more to come, but it's cell line dependent in terms of suitability. And one of the reasons is that some of the cell lines that we've taken, like I'll just give you one example. We've done this recently on an embryonal rhabdo that has an FGFR4 gatekeeper mutation, the V550L. And its answer was just to go downstream. Okay, so just one of the part of the talk I didn't emphasize is they tend to be really stuck on KIT and PDGFRA as the drivers. Yes, they can go down to NF1, PIK3CA, P10, but it tends to be like the suboptimal approach. And so then this system becomes very straightforward. You get out what you're hoping that you'll get out. With other cell lines that might or might not be more interesting, that you get something that takes a while to pin down and maybe as a model wasn't what you were after. We started this just wanting to know about resistance, but then we quickly realized for our purposes that it's a great way to generate pools that we then use as tools to screen drugs and so forth. But it's a mixed bag.
Hi, Bree Wilkie from Colorado. My question for Dr. Su. So really nice work. It's always great to have another immunocompetent model to try to tease out this immunogenicity. So you made this really nice case, and you have a lot of data showing increased T cell influx and all of that, but you argue that the CPG actually works earlier on the innate immune system, the myeloids and the monocytes. With all your CyTOF and your sequencing, do you find any differences? Do you find any mechanism to explain potentially the benefit of adding the CPG in the myeloid cells?
Really great question. I think the T cell is kind of the most obvious population that has increased and it's shown as very much activated. In our single cell, we actually observed kind of a dendritic cell population, like in the cluster of dendritic cells, like a cluster of them actually disappeared after CPG post-radiation therapy. We're also seeing that actually CD4 T cells seems to decrease after CPG post-radiation therapy. So kind of my hypothesis is that they might have migrated, because at the time point is day 3. So there's a possibility that they were activated and migrate to the lymph nodes to kind of do the cross-presentation with T cells. Unfortunately, we haven't saved lymph nodes. I would love to look at that, but I think that might be, so I think NTRR9 we see are definitely expressed on plasmacytoid dendritic cells. It actually is expressed on kind of macrophages, and it seems like like CDC1, like conventional dendritic, classic dendritic cells, class 1 as well. And I think those are all kind of pathways that possibly got activated by CPG, and then they have increased cross-presentation to CD8 T cells. Does that answer your question? Thank you.
Lee Cranmer, University of Washington. Question for Dr. Fletcher. What about with, if we're thinking about wild-type SDH-driven GIST, where there's now getting to be some data suggesting benefit from temozolomide, how do they look from a genetic instability standpoint? Do they look like a GIST, or do they look like an LMS?
Neither. Okay.
Oh, okay.
But from a standpoint of CIN or chromosomal instability, they're very simple. They tend, because it's a disease of methylation altering gene expression, then it tends that even the segmental deletions that one sees in a stable GIST, which is loss of 1p, chromosome 14, chromosome 22, and so forth, one typically doesn't find in an SDH deficient GIST. So we've thought about this a lot. You know, you could put the pieces together, but the whole puzzle isn't clear yet. If one took this to a logical extreme, exactly what you asked, one could think that absent maybe a strong KIT oncogenic driver, there might be more instability in those tumors. That's clearly not the case. But on the other hand, it's a totally different biological program with this propensity for hypermethylation as opposed to beginning with an oncogenic kinase. Our suspicion is that this concept will be generalizable to some other oncogenic tyrosine kinases. In other words, not entirely just specific, but it's not going to be a one-size-fits-all. They're driver tyrosine kinases, like let's take ETV6 NTRK in infantile fibrosarcoma, which is an incredibly chemosensitive tumor. Nobody would make a case that that's fostering genomic, I mean, they are genomically stable, but that it's making chemotherapies, for instance, inapplicable, which is our argument in GIST. So I think a lot of this is contextual in terms of not only the cell type, but the biological program. But great question.
Thank you.
And in the middle?
Hi, this question's for Dr. Chi. Really great talk. I'm curious your thoughts on the plasticity data that you showed with PRC2 loss. You mentioned it in terms of resistance mechanisms, but I wonder if you could speculate on how that might contribute to the pathogenesis of MPNST or other PRC2 deficient tumors. And as a corollary to that, do we know when the ED or SUSY12 loss happens in the evolution of these tumors?
Great question. I don't have a straightforward answer to, so certainly in the labs we've modeled, for example, MEK inhibitors treatment, and then in the PRC2 loss context, we can do single cell RNA-seq and then see how the single cells evolve in vitro, sort of in cell cultures, and then they do actually diverge. So you can see that they started as a relatively sort of homogeneous population, and then they diverge into different or subclasses with the activation of different pathways. But we're actually, and then compared to the PRC2 wild type, and then we're actually doing this in sort of using a special barcode so that you can really track from an evolution standpoint, and then also putting them in vivo. I think that's the more relevant setting, because clinically we already seen this. Our pathologists have been noticing that PRC2 loss have these like transdifferentiation into other lineages for a long, long time. We just didn't quite understand how that become. And then the second question is, clinically, we actually do see in clinical specimens, there is, as the plexiform in NF1 patients, if they have pre-existing neurofibromas, we do see there is a transition when plexiform neurofibroma gets transformed into high-grade MPNST, we do see a loss of ED or SUS12. And sometimes we also see when we do these immunohistochemistry of the histone H3 K27 tri method, we see sort of, if you will, we speculated it may be haploinsufficient loss. So they're not complete loss, and then we speculated, and then you can see pockets of them as well. But that's just the consequences. So I think that the evolution would have to be done by some kind of tracker that we can specifically track and then put them in the relevant setting.
And one last question. If you have any questions afterwards, please follow up in the break with the presenters. Thank you.
Thank you. Alex Gronchi from Milan, surgical oncology from Milan. Along this line, actually, I wanted to know whether there is, if there is any correlation between PCS2 loss and NF1 loss, and if there's any difference in the sporadic MPNST and the NF1-related MPNST.
Good question. So we had analyzed the MPNST arising from either in the setting of NF1 neurofibromatosis type 1 or sporadically arising MPNST as well as RT associated. We actually see significant all of them have NF1 loss. And then in the NF1 setting is 100%, but then in the setting of sporadic or RT-associated is somewhere around like 90-95%. And then they also lose CDKN2A. So it was actually pretty surprising to us initially when we sort of took 3 cohorts of clinically distinct MP and ST, but then when we analyzed them, and the tumor suppressor pathways are actually much more common. I wanted to say the PRC2 loss is a little bit less enriched in the NF1 associated MP and ST. And we sometimes see other or tumor suppressors are lost, but we haven't. But I think by far EED or SUS12 loss is the most enriched in each of the cohort, and then we see much more commonly with the RT-associated MP and ST, but small numbers. Okay.
Perfect. And that's concluding session 1. Thank you.